If we are solving a system of equations and both equations are linear, then there's only three different possible ways that it can come out. The first that we see here is the most standard case where both lines intersect in one point and we get one solution. So in this case, we can see the intersection is the point 1, 2, and that ordered pair would be our one solution. The second case is where we can see that if we have parallel lines, they never intersect. That's part of the definition of parallel lines. And because these never intersect, we don't get any solutions at all. The third case is what we call dependent. That's where if we were solving by graphing, maybe we would graph the first line, and then we would come through and graph the second line, and we would see that they are in fact the same line. Maybe the equations don't look identical at first because they're disguised, like solve for a different variable or multiplied through by a number, but they turn out to be equivalent equations. In this case, you can see that if you are looking in terms of intersections, every single point on this line, of which there are infinitely many, is a solution to the whole system of equations. And that's why we get an infinite number of solutions in this case. So with linear equations, systems of linear equations, these are the three possible cases that we can see. And we have three most common methods for solving these systems of linear equations. The first method is graphing, and that would be the same process as the process of solving a nonlinear system of equations by graphing. The second is substitution, which is also very similar to solving a nonlinear system of equations by substitution. So elimination is the main method that I would say applies mostly to linear systems of equations. And this one works very well even when the other two methods might be difficult. The idea behind the elimination method is that it's okay to add the two equations together. Right? So the idea behind the elimination method is that we do what we call adding equations together. But we don't just add them together the way they first appear. We want to modify them if necessary to make a variable drop out. We'll say x or y, it doesn't matter which one, drop out. And we call that eliminating the variable. That's where the elimination comes from. So if we look at this example that we have down here, 3x plus 2y equals negative 17, 2x plus 5y equals negative 4, the first thing we want to do is pick a variable to eliminate. In this case, x and y are about equally difficult. So I'm going to just arbitrarily choose y. So y is the variable that I'm going to target for elimination. What that means is I'm going to modify both equations, and I'm going to modify them by multiplying through by a number. That's the only thing I'm really allowed to do when I modify. I can multiply both sides of any equation by any non-zero number. I'm going to choose a number that's going to allow me to eliminate y when I add the equations together. I can see that if instead of 2y and 5y, I had 10y and negative 10y, then they would drop out. And I can see that I can get that by multiplying the top equation by 5 and the bottom equation by negative 2. So I have to multiply both sides of the equation by this 5. Multiplying every term in the first equation by 5 gets me 15x plus 10y equals, then negative 17 times 5 is negative 85. Multiplying each term in the second equation by negative 2, I then get negative 4x as my first term, negative 10y, sorry, I forgot to write the y up there, in my second term, and negative 4 times negative 2 is positive 8. We can now see how it is that when I get ready to add these equations together, the y's are set to add to 0, which makes them drop out of the equations. So that 15x minus 4x gets me 11x, and the equals are lined up, and negative 85 plus 8 gets me negative 77. When I add equations together, notice I really need to line up the like terms. The x terms are lined up, the y terms are lined up, even the equal signs are lined up, and the number terms are on the other side. This is usually the order in which we line up terms. Now I have a very simple equation in one variable, which is ready to solve for x by just dividing both sides by 11. This gives me x equals negative 7, and I can find y by just plugging this x into either of the original equations. I'll choose the second one arbitrarily. 2x plus 5y equals negative 4. This value of x I will plug in for this x to get 2 times negative 7 plus 5y equals negative 4. This becomes negative 14. Adding 14 to both sides gets me 5y equals 10. And then dividing both sides by 5, of course, gets me y equals 2. So I have as my solution the ordered pair negative 7, 2. I can check this by plugging it into both equations. I'll go ahead and show what that computation looks like really quick here. Plugging into the first equation gets me 3 times x, which is negative 7, plus 2 times y, which is 2, equals negative 17. And we can simplify this further to find that we get negative 17 on both sides. In this second equation, we would, this is this equation, plug in again negative 7 for x and 2 for y, and we see that we get negative 4 equals 4, which also, sorry, negative 4 equals negative 4, which also does in fact check. Right, let's rewrite that.